All right, so notice we're going to be writing a quadratic equation, and we have three pieces of information. You'll notice that there's also three unknowns that we're going to be trying to figure out along the way here, because I'm basically going to be trying to figure out what the A, B, and C values are. And so I can then, as a general strategy, take the 3 points, the three pieces of information that I have, and turn those into three different equations, and then I can use those three equations to solve for my three unknowns. All right, so that's a general strategy about what we're going to be doing here. Now let's actually start doing that. So first up, we're going to be doing f of 1 equals negative 2. All right, so f of 1, remember what that function notation means when we write f of 1. That's telling me that x, because it's what's inside the parentheses, is going to be 1. So I'm going to take that 1 and I'm going to plug it in for x wherever x appears. So this is going to become a times 1 squared plus b times 1 plus c. And what does that equal when I plug 1 in? F of 1 equals negative 2. Now, if you want to, you could actually write the negative 2 equals first, just to keep track of it. But we're used to looking at it more in this form where the variables are on the left, the numbers on the right, so I'm sticking with that. All right, now notice, I'm then going to be able to figure out what that equals. I'm going to be able to actually calculate out this 1 squared and all that. Although, I'm going to wait to do that here for a minute. I just want to worry about setup. So let's keep doing that with the other 2 points. So for the next one, we're doing ax squared again. In this case, x is 2. Plus b times x, which is 2, plus c equals, in this case, it all equals negative 5. And so that's using this one. And again, notice the function notation is just giving me a point. It's telling me x and y. Same kind of a thing there. And then we do it for the last one as well. All right, and there's our last equation. Now what we've formed then is a system of equations, because all of these are talking about the same a, b, and c values. That's why I put the curly bracket around it, because it's saying we're dealing with all the same values. Now, I do want to go ahead and simplify each of those equations. So, next step, I'm going to do all the squaring and all that. So like for that first equation, I have a times 1 squared. 1 squared, of course, is just 1, and a times 1 is just a. So that's going to be a, and I'm going to line things up a little bit here, plus, and then we do b times 1, which of course is just b, plus c, because notice our c's didn't change, is going to equal negative 2. We then repeat the process for the second equation, but in this case, obviously they're not 1s. We're going to be doing 2 squared. Okay, so 2 squared is 4, so it's a times 4, so I'm going to write that then as 4a. Plus, now do it for this one. B times 2, I want to write that then as 2b, plus c equals negative 5. And again, do the same for the last equation as well. And so now we have this system. Now that we have this system of equations, notice it's set up in a comfortable way. This is what we've been used to seeing over the last week or so. I mean, granted, this one has a, b, and c in it instead of x, y, z, but of course it's the same idea. So go ahead and solve this system of equations, please. Now, when I did this one, I chose to make the c's eliminate because they were all 1s. I just needed to make one of them negative along the way. And so by doing that, I combined first equations 1 and 2 to get that equation. Then I combined equations 1 and 3 to get that equation. Yours might have looked different depending on which variable you chose to try to eliminate. But then let's take our 2 equations. Remember, that's why we do that, is we take those 2 equations and we then combine those 2 equations as their own system of 2 equations with 2 variables. And so the way that I happen to choose to solve this one out, I ended up finding a first, so now that I know that a is 2, I can then go ahead and basically say I've done all the hard part, and I'll take that value and just start plugging it into other equations that had just a and b in them. So I ended up plugging that into the very top equation up there. And now that I know a and b, I can then take both of those and plug them into one of our original equations. And I think I'll plug it into that very first equation we had. And so I work that through and I find that c equals 5. Now, in this case though, I'm not done. I found out what a, b, and c are. That's all the work that I had to do in order to actually figure this out. But remember that the entire goal of this problem was actually to write the quadratic equation that is represented by that. So my final answer is actually going to be f of x equals, remember it was ax squared? A is 2, so it's going to be 2x squared plus bx. Well, b here is negative 9, so actually I'm going to make that minus 9x instead of plus a negative. And then plus c, and c here was 5. That then is our final answer. We've now written the equation of the quadratic that goes through those 3 points. And you'll notice the difference with this one. This time I didn't give it to you in terms of function notation. I wrote it as a point. But remember, it means the same thing. So like that -1, -17, that's the same thing as saying f of -1 equals -17. Function notation is just telling us our x and y values. So there's an example for our first equation, how that would look. Keep working on them from there. Now, if there's any potential trap in this problem, it's making sure that you actually got that -1 plugged in correctly. So check the signs there. You'll notice that our a value here ends up being positive, because remember that a negative number squared equals a positive. All right, and then we're basically just solving it from here. And I think most of you are about done with that process, so I'll go ahead and start giving you some answers about what to expect. Although, actually, I do want to mention one thing first. As you take a look at these, the first two actually play pretty nicely together here, because you notice that we got the b's already plus and minus. And we could use that to cancel out the b's, and that could cancel out the b's again with the first and the third. And that'd work great. But a couple of you might have decided instead that you wanted to actually have the c's cancel out. If you did that, notice what would end up happening with this top equation, if I actually, with either of them, if I multiplied it by -1, we'd end up flipping all of these signs. And notice that when I do that, and I add straight down, I'd be left with the b's only. When I tried to cancel out the c's from the first two, I'd also happen to cancel out the a values. And so that would give you a b value straight away. If you did it that way, you could then take that b value that you found and plug it into your equations, and then you could solve it from there. So different tactics, just depending on which way you want to do it. All right, so when we go through and we finish actually solving this through, you should find that a equals -3, b equals 10, and c equals -4. Now remember though, we're not done at that point. We have one step left. So at that point then, we go ahead and we put it back into that quadratic equation, that ax squared plus bx plus c. And so in this case, it would be either f of x equals, or you could also write it as y equals. That's perfectly fine there, especially since we gave them as points. That would make sense. It's going to be -3x squared plus 10x minus 4.